Solving systems of equations. This time we've got 3 by 3s, 3 variables, 3 equations. How do you even begin when you have 3 equations and 3 variables? Well, once you eliminate something, you're going to eliminate a variable. Do you have to stick with that a variable to eliminate? And, can you just switch to another one? And once you get to a 2 by 2, do you have to keep using elimination? We have a system of 3 equations and 3 variables. We're going to use the elimination to solve it, so we have to look at the coefficients of the equations and decide what's going to drop out. But first, I want to give you a hint, a tidbit, a tip. When you're doing this, when you're copying, be really careful with your signs. And I have a little trick I use because I know I can drop signs pretty easily. And I know I've done way too many of these using the wrong sign. So I have a little ritual I go through. After I've copied it, I look back at my original, and I look at the top equation, and I go positive, positive, negative, positive, 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 negative, positive. Okay, that one's good. And then I look at my second equation on my original paper that I copied from, or my textbook, or my worksheet. Positive, negative, positive, negative, positive, negative, positive, negative. Okay, good. And then I look at my last one, and they're all positive, and they're all positive. Because I don't often copy the wrong number, but I often copy the wrong sign. So that little 2-second trick will save you lots of errors. So then, now we've got to decide what we want to eliminate. And again, I've said, I know I make more problems with signs than I do with numbers. So it wouldn't be terribly hard to get my x's to drop out. What we're going to do is we're going to pick pairs of equations at a time. So I could pick the blue and the red and multiply the blue by -2, and that would make the x's eliminate. And then I could pick the blue and the green, and I could multiply the green by -3, and that would make the x's eliminate. But I know personally I'd rather do one where I don't have to change signs. It also wouldn't be terribly hard to get the z's to eliminate, because I could multiply this one by 2 and use it with the blue one, and then I could multiply this one by -3 and then get it to eliminate with the green one. But again, then I'm having to multiply by some negatives. So I'm going to choose to eliminate the y's. So I'm going to take my blue equation and multiply by 2. Then I don't have to change any signs. I'm going to use it with the red equation. So I'm going to bring my blue equation down exactly. Nope, I'm multiplying it by 2. If I multiply it by +2, my y's are going to drop out. So 6x plus 2y minus 4z equals 20. Okay, I check my signs again. Positive, positive, negative, positive, 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 negative, positive. Okay, and then I'm going to bring my red one down as is. I'm not going to change it. Okay, so we got 6x minus 2y plus z equals -2. So that one we didn't change. So now that we have that, we can do our elimination. We don't have any more y's. We have 12x minus 3y, or z, equals 18. Okay, what we're going to do is we're going to do that again, get another 2 by 2, or another 2 variable equation, and then we just do what we've been doing on 2 by 2s. Okay, so this time we said I can take my green equation as is, x plus 4y plus 3z equals 7. And now I'm going to multiply my red equation by 2. Notice, I had other options, but this way I didn't have to change signs on anything. Check my signs on that one. It's all positive. This one, I'm multiplying the red one by 2. So I've got 12x minus 4y plus 2z equals -4. Positive, negative, positive, negative, positive, negative, positive, negative. Times 2, times 2, times 2, times 2. I'm just double check because I'd rather take that 3 seconds now than make a mistake that's going to cost me lots of work. Now I've got 13x plus 5z equals 3. So now I just have two equations, two of them. So I can solve that. I could, at this point, I could use substitution, elimination, Kramer's rule. Probably wouldn't want to graph it, wouldn't be real accurate. But I'm going to continue with elimination. But if you have a favorite, or if you notice this one to be really easy to solve by substitution, go for it. So as I'm looking at my new blue and purple equations, the x coefficients are fairly large and they're both positive, so I'm not going to try to get that to drop out. I'm going to get my z's to drop out. So I'm going to multiply this one by 5, and I'm going to get 60x minus 15z equals 90, and I'm going to take this one and multiply by 3. Again, I don't have to change the signs, and I get 39x plus 15z equals 9. And so now my z's drop out. So 60 and 39, wow, that's a big number. It's 99. But look, we also have 99 over here. So x equals 1. So there's one of our answers. I got 1. Okay, now that we've got one answer, what would we do if we were doing a 2 by 2? Because really, from here down, or not all the way down, but from there down, what would you do on a 2 by 2? You would take your 1 and you'd plug it into one of the two variable equations. Well, I want to go back to one where I didn't do any multiplying, so I'm going to plug it back in here. I could plug it back in there, or I could plug it back in there. And I'm going to plug in that x value, and that's going to allow me to solve for z. So I'll plug it into the purple one. So we've got 13 times 1 plus 5z equals 3. 13 plus 5z equals 3 minus 13. 5z equals -10. Z equals -2. So now I've got my second variable, second value. Z is -2. Now that I've got that, I'm going to go back to either of my original equations, any of the three. I'll go back to the dark blue one just because it's on top, and I'm going to plug those two values into that top one. So now I have 3 times. Now I have 3 times 1 plus, oh, don't know why, minus 2 times z. Hey, where did my 2 go there? -2 equals 10. 3 plus y plus 4 equals 10. 7 plus y equals 10, so y equals 3. Now, I could just be done, and if I've got the answer, that's fine, but I should be in the habit of checking it. So I'm going to go to my red equation. I could pick either my red one or my green one. I'm going to pick my red one. Say 6 times 1 minus 2 times 3 plus -2 equals -2. And look, I get 6 minus 6. Minus 2 equals -2, and that's 0, so 2 equals -2. So it's not hard, it's just lots of steps. So I'm going to write out steps on this one. What did I do first? I picked 2 equations and eliminated one variable. Then I picked 2 different equations. Right? Obviously, one of them is going to be the same, but one of them is going to be different. And eliminate the same variable. Then I solve the 2 by 2 using the same rules we've been doing to solve two equations. Figured out what I needed to multiply by. And then let's use the math word instead of say plugged in, substituted those two answers into an original equation. And then I checked it because I care that my answer's right. And that's it. I'm not going to do another one myself, but I'll put up links to a couple other people doing these. There's lots of them on the internet, lots of places for you to find practice. Worked out in your book as well. So again, the key thing is to remember, once you pick a variable, you've got to eliminate that variable twice, because that's how you're going to get to your 2 by 2. If you eliminate the x's, then you should have two equations that have y's and z's in them. If you eliminate the y's, you should end up with two equations that have x's and z's in them. If you eliminate the z's, you should have two equations that have x's and y's in them. Doesn't matter which you choose, but make sure that you have a 2 by 2 you can solve. And then you just solve it like we've been solving them.